core statistical measures. One is sensitivity. It's the ability of the test to correctly identify those having the disease. Definition is true positive, untrue positive, plus false negative, and its clinical uses. It is good for screening tests, for example HIV, ELISA, and this D-dimer. These are have this good screening tests. Whereas specificity is ability of the test to correctly identify those without the disease. Specificity formula is true negative upon true negative plus false positive, and it's used as a good clinical uses, good for confirmatory tests, for example HIV, for example Western blot. Similarly troponin I, these are good for confirmatory tests. Now positive predictive value, its definition is probability that a person with a positive test actually has a disease. Formula is true positive upon true positive plus false positive. So as you can see here, what has changed, this false negative here, now it has become false positive. Rest it is same, and so this is the definition of the positive predictive value. That is probability that a person with a positive test actually has the disease. Whereas negative predictive value, its definition is probability that a person with a negative test actually does not have the disease. So its definition is true negative upon true negative plus false negative. And so you have to make this 2x2 diagnostic grid. 2x2 diagnostic grid you have to make, where you keep disease present and disease absent, whereas test positive, test negative. So these are true positive, these are true negatives, these are false positive, these are false negatives. And clinical pearls I can tell you. So to rule out, if you want to rule out any disease, that means you are screening a disease, that means you should prefer a test with high sensitivity. That is a test which has got few false negatives. Whereas if you want to rule in a disease, that is you want to get a confirmatory test, then you should prefer a test with high specificity. That is, they should have few false positive cases. So here few false negative, few false positive. And let's dive in further. For example, a new test for tuberculosis has a sensitivity of 795 and specificity of 85. What is the likelihood that a negative result rules out the disease? Since sensitivity is high, a negative result rules out disease. Now we'll discuss some other statistical measures. One is relative risk. The definition is risk. Here is probability. So it is the probability of an event, for example disease, in the exposed compared to unexposed. So probability of an event, or the risk of an event, or the event, here we are describing event as disease and probability as risk. So the risk or probability of an event or a disease in the exposed compared to unexposed, or relative risk ratio is A upon A plus B divided by C upon C plus D. So we are going to make a 2x2 table, and likewise we are making it like this: exposure plus exposure negative, disease plus disease negative, and total. So here A, B, C, D. So total is A plus B. Here likewise C plus D. So the risk or probability of an event or disease in the exposed is can see A divided by A plus B. Similarly, risk or probability of an event or disease in an unexposed is C upon C plus D. When we compare this, so we divide this whole, so we get relative risk ratio. So clinical interpretation of this is, if for instance relative risk is 1, it means there is no association. But if relative risk ratio is greater than 1, so it means exposure increases risk. Exposure increases risk. Whereas if it is less than 1, it means exposure is protective. Now, where are these things used? It's used in cohort studies and clinical trials. Cohort studies and clinical trials. So these are used. Now going to odds ratio. Odds ratio. OR. It means odds of disease in exposed group versus odds in unexposed. So odds of disease in exposed versus odds of disease in unexposed. So odds ratio is A multiplied by D divided by B multiplied by C. So likewise we are going to make this 2 cross 2 table. So exposed, unexposed, disease plus disease negative, A, B, C, D. We are describing this A, B, C, D like this. Now this odds in exposed is, so odds in exposed is A divided by B, whereas odds in unexposed is equal to C divided by D. That's why odds ratio is equal to A divided by B whole divided by C by D. So A multiplied by D divided by B multiplied by C. So this is odds ratio. Now, so clinical interpretation is, if odds ratio is equal to 1 means no association, but if greater than 1 means exposure is associated with disease, less than 1 means exposure is protective. So these, so relative risk and odds ratio. Relative risk is used in cohort studies and clinical trials, whereas odds ratio is used in case control studies. And when relative risk ratio cannot be directly calculated, in that case we calculate it with odds ratio. So difference between odds ratio and this is, so if we make a table, what is the difference between these two? For example, so relative risk versus odds ratio. So type of study, we do relative risk in cohort and randomized clinical trials, whereas this is used in case control or retrospective studies. Easy to interpret, yes, but it is less intuitive. And direct probability, yes, here direct probability is not present. Now common use is, we get a risk estimate, and here we get approximation of RR in rare diseases. And so relative risk comes from cohort, whereas odds ratio often used in case control. If disease is rare, then always remember, if disease is rare, then what happens, odds ratio becomes equal to relative risk. So to summarize, relative risk is equal to this A upon A plus B divided by C upon C plus D, used in cohort plus RCTs, whereas odds ratio is A multiplied by D, B, which is case controls.